Welcome to M1 class. We are going to starting with Unit 2. Special thanks to Dr. Mohammed Ahmed sir. Sir, thank you for your effort that you have put so that we could reach to this point. In our previous class, we have seen Rollo's theorem, Lagrange's theorem, and okay. So today we are going to solve problems on Rollo's theorem. These can be asked in SAQ for 2 marks, or it could be asked in LAQ also with the theorem. Okay, they are very easy. If you have learned the theorem, you can easily solve it. Okay, verify Rollo's theorem for the function f of x is equal to x minus a power m, x minus b power m. This is the function given to us in closed bracket a comma b, close interval a comma b. So what was the condition in Rollo's theorem? Number one, it was that it should be continuous. Number two, it should be differentiable. Okay. Now first of all, we will see does it satisfy the conditions of Rollo's theorem. If it satisfies the conditions of Rollo's theorem, then we can apply Rollo's theorem. So what is Rollo's theorem? F dash of c is equal to 0. So c f dash f of x is equal this constant at open interval, sorry, close interval a comma b. Okay. Next, if f of x is differentiable or not. Okay, this is the function given to us. We are differentiating the function. Okay, the differentiation of f of x. This is in the form of uv, right? So u v dash plus v u dash. So by applying differentiation, we are differentiating the equation. Then we are taking common a minus x whole power m minus 1 and x minus b power n minus 1 we are taking as common. Okay. Hence we know that f of x is differentiable at open interval a comma b. So f of x is continuous at close interval a comma b, and it is differentiable at open interval a comma b. Okay. So if it is, then what we have to do is f of a, we have to equate f of a and f of b, and we have to check are they equal or not. So what is f of a? Instead of writing x, we are going to substitute a. So f of x is equal to a minus a power n into a minus b power n is equal to 0. A minus a will be 0. 0 into anything will be 0. Similarly, f of b. Instead of this x, you have to substitute b. So in this equation, b minus a power m into b minus b power n. B minus b will be 0. 0 into anything is 0. Hence, f of a is equal to f of b. It satisfies all the conditions of your Rollo's theorem. Then we can apply the Rollo's theorem. What is Rollo's theorem? F dash of c is equal to 0. Now let's apply. Instead, okay, in the differentiated equation, instead of x, we are going to substitute c. So we have got this differentiated equation f dash of x, right? F dash of x is equal to, we got this equation. Instead of this equation, we are going to substitute, instead of x, we are going to substitute what? We are going to substitute c. If you substitute c in this, we will get the equation as this. Now, c is equal to a or c is equal to b. Okay? Or n into c minus a plus m into c minus b is equal to 0. Okay, and a doesn't belongs to open interval a comma b and b doesn't belong to open interval a comma b. So just simplify this. Okay, n into c and c, n into minus a minus na. Similarly, m into c mc, m into minus b minus mb. Now take this na and mb to your right hand side. Okay, then take c as common. If you take c as common, what will be left? F plus n will be left. Send this m plus n to your right hand side. Here it was in multiplication, so it will be equal to division. C is equal to na plus nb by m plus n. Belongs to open interval a comma b. Hence Roller's theorem is verified. We got the value of C. Roller's theorem is verified. Next question. Discuss the applications of Roller's theorem to f of x is equal to x square minus 4x by x minus 2 in closed interval 0 comma 4. This equation f of x is given to us. Okay, and we can see that x is equal to 0, then f of x will be equal to infinity because of the denominator. If denominator, what is 1 by 0? 1 by 0 will be, what is 1 by 0? It is infinity. So if denominator becomes 0, then function will become infinite. Right? So at x is equal to 0, x is equal to 2, at x is equal to 2, f of x, this equation is discontinuous. Because what is infinity on this graph? Infinity means it will be like this. This equation is going like this. Here it will be infinity. Okay. There is no such point over there, so it will become infinity. So it will be definitely discontinuous. So 2 belongs to open interval, closed interval 0 comma 4. F of x is not continuous. Is f of x continuous? No, because add 2 between 0 and 4, between 0. Consider this is 0. At this 2, it is becoming infinite at 4. This 4. So this function is becoming discontinuous at 2. Hence Rolle's theorem can't be applied because what is the condition? Number 1, function should be continuous. Okay, it should be continuous. It should continuous and it should be differentiable. Okay, so it is not satisfying the first condition, therefore we can't apply the Rolle's theorem. Next question, verify Rolle's theorem for this equation. In this also equation also same. Given f of x is equal to x square minus 4x by x plus 2. At x is equal to minus 2. So in this graph, here it is 0, here it is 2 and 4. We have to discuss between these 0 to 4, as it is said to us in the question, between 0 to 4. But the function, see the denominator, x plus 2 is equal to 0. If x plus 2 is equal to 0, then it will become discontinuous. So it means that x is equal to, if x is equal to minus 2, at this point x is equal to minus 2, this function f of x will become discontinuous because it will become infinity. Okay, but minus 2 doesn't belong to 0 comma 4. Okay, closed interval 0 comma 4. F of x is continuous in 0 to 4. This equation f of x, it is continuous between 0 to 4. It is continuous, right? This function, it will be continuous. It's f of x. Now we have to find a point C over here. If you draw the tangent, it should be parallel to your x-axis. Okay? How we are going to find this? F dash of x. Find the differentiation of this equation. Okay, it is in the form of u by v. So u v dash minus v u dash by v square. Apply the formula. Apply u by v rule. Okay? u v dash minus v u dash by v square is the formula. So if you apply the formula and simplify, you will get this as the answer. Okay? And this is the final answer. F dash of x is equal to x square plus 4x minus 8 by x minus x plus 2 whole square. This will be your final answer. And f dash of x is differentiable at open interval 0 to 4. Okay, then at 0, what is the next condition? F of a should be is equal to f of b. F of a should be equal to f of b. Applied f of 0, f of 4. If you substitute f of 4 or f of 0, the answer will be same. Since now this condition, the third condition, f of a is equal to f of b is also satisfied. Now, so all the conditions of Euler's theorem have been verified. All the conditions have been verified, right? Now, then we can apply the Euler's theorem. What is the Euler's theorem? F dash of c is equal to 0. So you have f dash of x. Instead of x in this equation, substitute f dash of c. Instead of x, substitute c. So c square plus 4c minus 8 by c plus 2 whole square is equal to 0. Send this denominator to that side and it will be multiplied with 0 and will become 0. Hence you will be left with a quadratic equation. You can use the formula minus b plus or minus root of b square minus 4ac by 2a to find the roots of this equation on this graph. Okay, on this graph. Okay, between 0 to 4, right? So on this graph between 0 to 4, here we will have 0. We are having a quadratic equation, so then what will be the shape of a quadratic equation? Okay, this will be the shape of a quadratic equation. So we should get 2 points, that will be C1 and C2. So if you solve this, you will get it. Okay, minus 2 minus 2 the quadratic equation will be just like this. Okay, it won't be like this, it will be just one curve. It will be like this. And the curve, okay, this curve will be like this. Z1 C1 is equal to root 3 minus 2 belongs to 0 to 4. Okay, open interval 0 to 4 will get the answer. Okay, we are solving the quadratic equation using the formula minus b plus or minus b square minus 4ac by 2a. Next question, this question is homework for you. Okay, so first of all, you need to check that it is continuous or not. If it is continuous, differentiate it. Yes, it is differentiable. You can use the UV rule, or you can multiply it and find that derivation individually. It will be differentiable. Then you have to check f of 0 is equal to f of 1 or not. it will be equal. Then apply the formula f dash of c is equal to 0. Simplify the equation and you will get the answer. Solve this question and share it with me personally. Verify Euler's theorem for the given function sin x by e power x. Okay, on 0 comma pi. Okay, close interval 0 comma pi. So now we have to check if it is continuous or not. So we can see that it is continuous. Okay, the equation of sine is continuous, right? Between 0 to pi. So yes, it is continuous. Okay. So now is it differentiable? Yes, it is differentiable. Okay. It is differentiable. Then f dash of x exists on open interval 0 to pi. Then check f of x, f of a is equal to f of b or not, and it means that f of 0 is it equal to f of pi. Just check that out, is f of 0 is equal to f of pi or not. Yes, it will be definitely equal. Okay, it will satisfy all the conditions of Euler's theorem. Then c belongs to 0 to pi. Okay, open interval 0 to pi. Since it has already satisfied all the conditions of Euler's theorem, you can apply Euler's theorem formula. What is Euler's theorem? Euler's theorem formula. The formula is f dash of c is equal to 0. So we have already found f dash of c. In this f dash of c, substitute, simplify, and you will get the answer as c is equal to pi by 4. Okay, hence Euler's theorem verified. Next question, discuss the applicability of Euler's theorem for f of x is equal to modulus of x. So what is modulus? Modulus, if you put any negative number into modulus, it will become positive, and if you put any positive number into modulus, it will stay positive. So our modulus is a positive function. It can make any number which is negative to positive. Okay. So f of x is equal to modulus of x in closed interval minus 2 to 2. As you can see in this graph, this will be the graph of modulus function. Okay. F of x will never be negative, so it will be like this V shape. So now given that f of x is equal to, now as you can see between minus 2 and 2 the function is continuous. So definitely is continuous. And next, if we can differentiate, f of x is differentiable at all points. Yes, we can differentiate it at all points. Okay, except x is equal to 0. We can't differentiate it at x is equal to 0. Okay, it is not differentiable at x is equal to 0. So since it is not following this law that f of x should be differentiable between closed interval minus 2 comma 2, hence Euler's theorem can't be applied. Okay, we can't apply this Euler's theorem. Practice each question, okay, at least 3 times to 5 times. It will be very helpful for you. Special thanks again to Dr. Mohammed, sir